Well, hello everyone. Welcome back to Adrian's Digital Basement. On today's video, I am back on the Apple IIgs that I worked on in the last video. As per usual with my repair videos, I recommend you watch that first, as we will be picking up where we left off in that last video. Now, for a quick recap, the machine was given to me by a friend of the channel, James, and it was sent to me kind of in an unknown, non-working state. So in the last video, I serviced the power supply and then I started troubleshooting the machine. It seemed that when I turned it on, it would just do really random things like show a black screen with a little bit of static on it, and I really couldn't get much more out of it. So to help troubleshoot this machine, I broke out the OneRom, it's an EPROM emulator, and I loaded up some custom ROM images onto here, including an Apple IIe ROM and the Apple II dead test ROM, both of which aren't designed to run on a 2GS, but strangely enough, do kind of work. Well, when I say kind of, they were working. I could tell they were running because I could hear the sounds out of the speaker of like the beeps and stuff like that, but nothing was ever getting updated on the screen. So there's definitely some kind of a fault on here. Now, what I don't know for sure, of course, is if those ROMs always behave that way on a 2GS. I've never really tried that before, or if that's really just the fault of what this machine is doing that's exhibiting itself in that way. I have another 2GS here, so I can use this if I want to troubleshoot, like maybe run those ROMs on this to see how they work. But I want to refrain from actually testing out this known good 2GS because, of course, you might be working on a repair of a computer that you don't have a spare or access to a spare. So it's really good to go through the exercise of trying to solve the problem based on the evidence you're gathering by, troubleshooting and testing the machine, and then see if you can get to the bottom of it without breaking out a known good machine where you can kind of compare and stuff like that. So that's what I want to do in this video. I want to see if I can get this machine fully operational. I don't really know what's wrong with it still. I kind of left off the last part with a bunch of evidence without an actual solution. But I've been doing some reading in the technical manual for the computer, and I have some leads as to what might be going on. So without further ado, let's get to the troubleshooting. So the machine sitting on the bench is exactly how I left it, or we left off in the last video. I haven't touched anything. The floppy drives are still sitting here. The Apple II VGA card is still plugged into the machine. But I have done one thing since I left off in the last video, and I upgraded the ROM from the regular Apple IIe unenhanced ROM to the Apple IIe enhanced ROM. The main reason for that is I knew that the enhanced ROM for the IIe actually has a RAM diagnostic built into it. I didn't mention this in the intro, but if you recall back to part one, when I had the Apple IIgs ROM in this machine, I was able to push Open Apple and Closed Apple Control Reset, and that actually started the Apple IIgs diagnostic, and it was kind of running through. We were getting color borders, and then it was crashing out. So it was definitely detecting some kind of a problem, but because it can't display anything on screen, that diagnostic ROM does display its errors by printing them on screen, and well, we're just not seeing anything. I was thinking one thing I might do is break out my working 2GS, plug it in, and just let it run through its normal diagnostic so we can compare what a good diagnostic routine looks like versus the non-good diagnostic routine. One thing that's kind of frustrating to me is that there is plenty of documentation about the Apple 2GS diagnostic routine. In fact, there's an Apple technical note here from Apple themselves, and it talks about all the various routines that run and how to decode the error codes. And I know I've made a video on this channel, I think that was like 4 years ago, where I troubleshooted a 2GS. It just had bad RAM, and the diagnostic was able to kind of tell me which chips were bad, which bit was bad, and stuff like that. And I was able to kind of get to the bottom of which chip it was. The thing is, we know that as the diagnostics run, we saw it, the border color changes as each test's run. But nowhere on here does it say which color border relates to which test. In fact, I've scoured the internet and I found all sorts of people talking about this diagnostic information. It's basically this information just distilled into a post on a forum or something, and no one ever mentions the border color. So that's the only thing we have to go off of when we run the diagnostics on this machine, the 2GS diagnostics that is the border color where the failure is, and there's just no explanation of how that all works. So basically, to use this diagnostic, you absolutely have to have a machine that has working text display so you can read the diagnostic error code to try to figure out exactly where your problem is. Doesn't really help us though, does it? So that's what gave me the idea to take the enhanced Apple IIe ROM and load that into the OneRom and see if I could run the Apple IIe diagnostics, because those are very simplistic and it's just going to test the, well, I think 128K of RAM. And let's see what that does. Okay, so when we turn this on, when the Apple IIe ROMs are in there, what happens, and I don't really get why this is happening, and I haven't tested this on the other machine, is you get a black screen for a little while. But if you just wait a while, it will actually boot up, but the screen always stays black. Now that's probably related to the fact that there's some soft switch on the 2GS that's not set properly. So it looks like it's dead right now, but I'm going to hit Open Apple Control Reset, and the beep is there. It's just quiet. So it's beeping. So right now we are actually in basic, and I can tell because if I just type GR, like we're in low res graphics mode, and type text, we're back in text mode. So with the enhanced Apple IIe ROM, if you have one of these on your Apple IIe, if you hold down both Apple keys, Control Reset, it goes into a diagnostic mode where it normally shows you kind of a bunch of random characters in low res graphics mode. And then after a while, you hear this beep, and I think it says System OK, something like that. So I'm going to hold down all the keys with Control and Reset. Okay, I think the diagnostic is running right now. Now, of course, we're not seeing all that random garbage, which I think is like part of the RAM checking. I think all this diagnostic test really does is just check the RAM. But what it does do is when it's done, it makes a high-pitched tone that kind of flashes between text mode and graphics mode, and then it says System OK. Let's see if it does that. There it is. That was it. So there was a high-pitched kind of like chirping sound, and it was flashing between text mode and graphics mode. And right now it should be saying System OK. Now on a real IIe, when you're at this screen, if you just hold down both Apple keys without pushing Control Reset, it will run the diagnostic again. And here I'm going to do that. There it is. So now it's running the diagnostic again. We're still not seeing the graphics properly. It should be showing a bunch of random colors on screen, but I think the diagnostic is looping. And definitely that chirping sound that it said is the all system RAM is okay sound. And it just takes, there it is. Okay. So I'm quite confident in saying that just like the dead test ROM, which we had on here, this is telling us that the ROM code that's running through the CPU is able to access all 128K of RAM properly. And of course, this is the lower 128K that the Apple IIe has, since this ROM doesn't know anything about the extended memory and the enhanced processor that's on the 2GS. This is, for all intents and purposes, just running as an Apple IIe right now. And that's all made possible by the Mega 2, which is essentially the Apple IIe chipset, all on a single chip. So what I want to do is let's just review all the evidence that we've seen about what this machine is doing exactly. So in this note, I've just sort of written down all the things that I've seen so far. So ROMs work, keyboard works, the sound is working, because when we had the 2GS ROM in there and I hit Open Apple Control Reset, we heard the Apple 2GS dong, bong, whatever, that sound it makes, which is coming from the sound chip. We also know that normal sound is working, like Apple IIe sound, so I'm going to put that on here. Now, that's different because the way Apple II sound works is there's a single register. If you just read that register, it makes a tick out of the speaker. So if you just read it continually, very high speed, like say at 440 hertz, you'll make a 440 hertz square wave tone out of the speaker. That's a different sound path on the 2GS than the wavetable synthesis that comes out of the Apple 2GS sound chip. But it sounds like both the Apple 2GS sound and the regular Apple II sound is working. It's quiet, but it works. The dead test RAM test is working. So that only tests 48K, but I can tell 100% with the auditory clues that the dead test ROM makes when it finishes its RAM test, it's testing 48K properly. And now we know that the Apple IIe enhanced RAM test is working as well. I'm not sure if this is 64K or 128K, but it's at least 64K that it's testing and it's telling us is okay. We know that the Apple 2GS diagnostics fail, but we can't really tell where. And then next we know that the text and graphics doesn't really work properly. So while we can switch between text and graphics mode, we definitely can't update the screen memory and have it show up on the text screen. Now, part one, there were some time where I saw a little bit of text, like from the machine language monitor, oddly enough, on the second text page. Don't know what was going on with that. But other than that, I've never been able to get any kind of text to render properly. And then as for graphics, it kind of works a little bit, but not totally. But that's actually a really important clue. And then the final clue we have is that the Apple II VGA card, it's actually A2 VGA, that card, what it does is it monitors all the activity on the slots. And if it sees any writes into the screen buffers, say text or graphics, and it sees any reads or writes to the registers that are used for the Apple II to like switch between graphics mode, text mode, stuff like that, then it just replicates that in its internal buffer. And in part one, without a doubt, we really saw a replication of what was happening on the screen of the 2GS through the composite output and what was on the Apple II VGA card. So when we saw a little bit of machine language monitor on the second text page, it was also there on the Apple II VGA card, which meant that it picked it up across the bus. So back on the Apple 2GS, if I hit Control and Reset, the beep is happening, but it's very quiet. But we are currently in basic, and I know this because I can type GR, I can type HGR, and I can type text, and we can kind of change modes. Well, that was a typo on my part. Now, here's something that's really interesting. If we type HGR2, This is showing us the second page of high-res graphics. Now, this is what's really funny. Notice how when it switched to this page, it was mostly white, there was a little bit of garbage there, and then those black lines kind of drew in. And that's because when you type HGR or HGR2, the AppleSoft basic command, what it does is it tries to clear the high-res screen buffer, because normally it's just full of garbage when you first turn on your computer, so it clears it for you. And on the Apple II, it's kind of confusing if you're not familiar with it. The way the text mode and the graphics mode work is it's not just like a linear buffer in RAM that's displayed on screen. It's actually interleaved. So as you're writing into the screen buffer, well, the line would be at the top, and then the next line would be kind of a third of the way down, and then the next one 2/3 of the way down, and it would kind of loop. And that's why what you saw there, and if I power this on and off and I kind of show you and just pay attention to as those lines draw, you'll see what I'm talking about as it tries to clear that screen. Okay, so I reset the computer. Hopefully the whatever is in RAM faded from memory. Okay, so we type HGR2 and just pay attention to what it looks like, and then you'll see it try to clear the screen. Okay, that didn't work because it almost felt like we have some serious persistence of RAM happening on this machine because those lines were still there. Okay, I'm going to take a different tactic. Call -151, and I'm blind typing this, so sorry I can't kind of show you what I'm typing. I'm going to write directly into high-res graphics page 2. Pay attention to the upper left corner. Address 4000, and I'm going to write FF there, and you're going to see it turn white. Up, see that little white chunk that appeared there? That was me writing into the screen buffer, and it obviously worked. Now what I'm going to do is I'm going to type a command that copies. I'm going to try to do this from memory here. It's going to copy that FF that made those pixels appear into the entire high-res screen buffer. So the way this works is 4000 dot, I can't remember the top of the spaces. I think it's 5FFFM. Okay, and watch those black lines. They should disappear. Okay, see that? They disappeared, but not fully. Like, we still have that garbage that's left in there, but I was able to write to some of the screen memory here, and it definitely, well, it worked. And I can prove this because I'm going to fill it up with 0 zeros, and you'll see those lines will come back. So I'm going to write to address 4000 00. So top corner of the screen, see a little chunk appeared there? And now I'm going to copy that 4001 to 4000.5FFF. I'm going to copy those black pixels to the entire screen. It should make the whole screen black if the machine were working properly, but it's not. See? Just those lines appeared. So when I'm writing into the screen memory, all that's actually making its way to what we see on screen is just some of the pixels. Obviously, I was unable to affect those garbage bands completely. Those were untouched. And then all those lines in between the black lines, all those white areas, that was also untouched. Now here's where this gets kind of interesting. And I know this is going to get kind of deep, and the Apple II, even the original 77 Apple II, it's just weird how things worked. And all of that has been replicated in the 2GS because to maintain compatibility, they had to keep all of that. So a lot of this is weirdness, but believe me, I'm going to get somewhere with this, with the ideas of what's going on here. But I'm just trying to demonstrate what's going on exactly so we can see all the symptoms to then try to figure out what the problems are. I'm going to switch the video input over to the Apple II VGA card. And remember, this card is just watching writes to the slots, and anything that gets written across the slots, it replicates into its own frame buffer. Now, from what I can tell, when the Apple II VGA card initializes, even though it's like a simulated Apple II frame buffer, it's just full of like this random static that's happening here. So that's why it looks different than what we saw on the Apple II GS composite video, which was mostly white with those like bands of trash. This is just all trash. The thing is, you can see the black lines are there. They are there. And I can show you that if I write FFs in there, those black lines are going to fill in with white lines. So I'm going to do that right now. So 4000, because we're on the second high-res text page, I'm going to write FF into it. That should put there a little chunk of white up at the top there. And then the command to copy that to the entire screen would be 4001 less than 4000.5FFFFM. There it is. The reason why I was doing that whole demo is I just wanted to kind of demonstrate that what we're seeing on the screen of the Apple II through the composite video, which is being generated by the Mega 2 chip, that's the Apple II emulator on a chip, is exactly the same as what the Apple II VGA card is seeing. That has a big implication. If the problem on the 2GS were something to do with the RAM, so imagine the RAM that the Mega 2 is using to draw the graphics to screen, say there's something wrong with that RAM, or it was like missing or something like that. Well, obviously the Mega 2 would never be able to display text or graphics properly, right? The thing is, the Apple II VGA card does not rely on the onboard RAM at all. All the Apple II VGA card does, as I mentioned a few times, is it just snoops the bus. So anytime you're trying to write into the RAM, whether the RAM exists or not, the Apple II VGA card will see that write for like the screen buffer for high-res page 2, and it will display it. It doesn't matter if the RAM is working on the computer or not. It's a great diagnostic tool for that exact case, because if you have an Apple II Plus or 2E or whatever, and you put that card in there, even if the RAM is broken or the video display circuitry is broken on the 2E, as long as the CPU is able to write into the RAM, the Apple II VGA card, if it can see it across the bus, it's going to show it. But what's happening on this machine is that what the Apple II VGA card sees, those lines that are being drawn on the second page, and what the Mega 2 is displaying out of the video port is the same. It's those high-res lines that aren't really able to fill up the whole screen. Okay, so keep that in your mind. The other thing we're experiencing here, though, is that the CPU is able to read and write to the memory perfectly. So when we run the RAM diagnostics, both the dead test ROM diagnostic and the Apple IIe RAM diagnostic, it passes perfectly. On top of that, AppleSoft Basic works. That requires RAM to work. If the machine language monitor is working, that requires RAM to work. So the CPU is running code from the ROM and it's just working. Like, it's having no issues with RAM access at all. All the RAM issues are happening when the Mega 2 is trying to read out of the system RAM and display it onto the screen, which is what the Apple II does constantly. Just when the Apple II is powered up, that's what the Apple II does. It displays chunks of memory, either text mode or graphics mode, depending on how your switches are configured, and just displays it on your screen. Okay, so you could be thinking, well, maybe the Mega 2 is bad and it's like not able to look into memory properly. Maybe that's why it's not working. But that's where the Apple II VGA card comes in handy, because now we know the problem isn't specifically with the Mega 2. Well, we don't really know for sure, but it doesn't seem like it's with the Mega 2 because the Apple II VGA card also is just not seeing those writes into the memory. So whatever is between the CPU and the Mega 2, or the RAM the Mega 2 is using, and I guess the Apple II VGA cards, that's got to be where our fault is. Something there must be connecting those things to where the CPU is, because the CPU obviously is able to talk to the memory and that's working perfectly, and yet writes to memory that should show up on screen and should show up on the Apple II VGA card, those aren't working. So that's where things kind of get complicated, because we're running on an Apple II GS and not on just a normal Apple II. This thing has a lot of, I don't know, let's call it workarounds that allow this thing to be faster and have all these extra features and still maintain full backwards compatibility. So when we go to the schematics and you start looking around on here, it gets a little bit confusing because there are a bunch of different data buses and address buses. So BA bus, MD bus, and this is the Mega 2 page. We have D bus, MD bus, BA bus, A bus. There's a whole bunch of buses, right? So it's getting a little bit complicated. Now, the thing is, I've sort of talked about this in the first part, I think. There is RAM that hangs off of the Mega 2. This is this main memory. It's called standard RAM on the motherboard. This is what the Mega 2 is using. And in part 1, when I was running these like dead test ROM and I was running basic, I was thinking that in Apple IIe mode, which clearly the computer is in right now because it's working, it's running the ROM, I thought that this RAM is what entirely would have been used for everything. So like all of basic and machine language monitor and any writes and reads out of RAM, like with the dead test ROM, would be testing this memory. Because it kind of makes sense, right? Because we know we're running in 2E mode and the Mega 2 is what enables that. And this is the RAM that's, standard RAM that is used for that stuff. But I don't think that's actually the case. Now, I started reading through the Apple II technical manual or hardware reference manual, and it's a pretty big book, and unfortunately, it's very low quality scan. I don't know if there's a better quality scan, but this is all I could find. And it's talking a little bit about the memory shadowing of how this thing works and the memory layout of the Apple II GS. And it's that FPI, which is like fast page interface or something like that. That's the chip that is controlling the fast memory. Well, it's actually controlling the entire memory map on the 2GS. This is the FPI chip right here. It sits right next to the CPU and next to the graphics chip. And when we look at the memory map, you can see here that there are banks, and that's part of the 65C816, by the way. There are 256 banks of 64K memory. And most of them are controlled by this FPI chip, and they call it fast RAM. And the fast memory that's on this computer, which is the RAM chips that are over here, that actually is this stuff right here, 1 meg, or 256K 2GS. This is 256K 2GS. So starting at bank 0 all the way up through, I guess, 7F on both these machines, that is fast memory. And then we have this shared slow RAM that's controlled by the Mega 2. It's bank E0 and E1. And then we have above that a bunch of ROM space. So back to what I was saying, when you look at this, you're thinking, okay, well, when the machine's running in 2E mode, we're probably going to be using this RAM here in E1 and E0. That would be the Mega 2 RAM. That's the 128K that the Apple IIe has. But I started reading through this manual, and I don't think that's actually what's going on with this machine when you first power it up. It looks like it powers up in Apple IIe mode, which is why it's able just to run the Apple IIe ROMs without any issues. Now it says memory shadowing is the process of reading or writing one memory location in two different banks. Enabling shadowing duplicates the I/O locations and portions of the video buffers you select via the shadow register into the shadow-enabled RAM banks. Writing into these locations in banks for which shadowing has been enabled results in duplicate writes to these locations in banks E0 and E1. Direct access to the I/O and video buffers is not inhibited and may still be obtained through E0 and E1. See the I/O address space. Okay, so this is that Mega 2 memory space. That is the standard slow RAM, this stuff down here in this part of the board. Well, we can look here. This is the entire Apple IIe memory space, 128K of it. We got high-res pages, text pages, I/O space. Those are the soft switches for like making a speaker beep and changing graphics mode and stuff like that. All of this actually exists in the bank E0 and E1. Now the thing is, when you're running code on the 2GS that doesn't know about 65C816 or banking, it's not going to even use the bank registers at all. It's just going to write to the memory space like a regular 6502. And it appears what that means is any read and writes to memory on the 2GS when you first power it up are always going to just go to bank 0. And then there's bank 1 as well, which happens to be the second 64K, because remember, the Apple IIe has 128K. So when it's talking about shadowing here, it's not very specific, but what this is saying is that when you have this shadowing turned on, any writes to page 0 are going to end up in E0, and any writes to page 1 are going to end up in E1. Now, on the next page, it talks a little bit more about this. The purpose of the shadowing is to provide the optimum system speed. By shadowing the I/O and video buffers in the high-speed FPI address space, only write instructions to the video locations require the system to operate at 1 megahertz. And that's because, of course, the Mega 2 doesn't really know how to run at a faster speed. So anytime you're writing to its memory space, due to timing constraints or whatever, the system's got to slow down to 1 megahertz. A write instruction actually writes to an address in both banks, the Mega 2 bank, E0 and E1, and the shadow-enabled bank, 00 and 01. Read instructions access the high-speed shadow bank only. So when you're reading from memory, it only reads from 00 and 01, and shadowing therefore helps minimize the impact of video performance updates on overall system speed. Now there's a register on the 2GS that allows you to enable or disable shadowing between this page 0001 and the E0 and E1. And to control that stuff, you use this register CO35. I apologize for this low resolution, but that's just the best we have here. So this register allows you to inhibit shadowing on text page 1, inhibit shadowing on high-res page 1, on high-res page 2, so on and so forth. And you can even inhibit the I/O and language card operation shadowing. What those are the soft switches I was talking about. CO35 itself is one of them, but I guess that one's maybe not affected. I don't know where this one lives. But any of the Apple IIe or Mega 2 registers, like the beep speaker, changing graphics mode, stuff like that, that's all going to be in this I/O space. It's bit 6. And when you look at the register values, it actually talks about that. So anytime the value is 0, it actually enables the shadowing. Anytime you set it to 1, it inhibits it. So generally, you want all the shadowing turned on for all these various Mega 2 functions, especially when you're running legacy Apple II code like we are with the Apple IIe ROM. We need the shadowing turned on because it's going to write into page 00 for the text updates, for instance, and that's this text page 1. And when it's set to 0, that bit in the register, then shadowing is enabled, and it should copy, or at least it should write anything that's written into page 00 also into the Mega 2 RAM, which is this RAM down here. So to validate this shadowing thing is actually working or not working, I'm going to manipulate it manually. So first let's get into basic and let's bring up HDR2. There it is. And I'm going to go to machine language monitor. I'm going to try to write to FF to the top, which there we go, wrote a little chunk to the top. I'm going to copy that into the entire screen buffer, which should fill in those black lines, the ones that are working at least. There it is. It worked. Okay. So now I'm still in machine language monitor. I'm going to manipulate this register. So I type CO35 : I'm going to turn off everything except 6 and 7. So that would be a 3F, or I'm going to turn it on, I mean. So that's going to inhibit the shadowing, except I should still have control over the I/O registers, but I don't think that necessarily matters. So now if I type 4000, and I'm going to put a 00, so it should write black to that top corner. I don't think it did it. I've typed the same command to copy what I just wrote to the top corner into the entire thing, and yeah, nothing happened. Okay, now let me change this register back, CO35. I know I'm just blind typing this, you can't see anything, I apologize. I'm going to write 00 to that register, which should turn all the shadowing back on. It's no longer inhibited. Now, if I write 4000 and I type in 00, we have a little black thing in the corner there. And now I type 4001 to 4000.5FFFM. There we go. Shadowing is working again. So that confirms without a doubt that the shadowing register is working. I can disable shadowing from the 00 and 01 page into E0 and E1 by setting that to 3F, which sets bit 5, 4, 3, 2, 1, and 0. It leaves 6 and 7, well, it leaves them as 0. And using that machine language command, I tried to fill the high-res page 2 with all black. It didn't. And then all I had to do was change these all back to 0, which turned shadowing back on. So that would copy what was in page 00 into E0, ran that same command in machine language monitor, and there we go. We are seeing those black lines. All right, so this tells us a lot. This tells us that the shadowing functionality is working. The connectivity between the main memory, or the fast memory, which is where the CPU is executing code in right now, and the standard RAM, the Mega 2 RAM, which is what is used to display to the screen, is actually working. So that copy process works. Right, so back to our technical manual, there's a little bit more on here. So bank 00 memory allocation. This bank preserves many of the features found in the 64K memory of the Apple IIe and IIc that make it possible to run programs originally written for those machines, or for the 2 Plus. Most of Bank 00 is available for storing programs and data. However, a few pages of 00 are reserved for use with the monitor firmware and basic interpreter. The direct page works differently. When the 65C816 is in emulation mode, which is what it's in when you first power it up, the direct page is loaded at address 0000 at bank 00, like the 0 page in a 6502 microprocessor 64K address space. That confirms to us that when the Apple IIgs powers up, it's in an Apple IIe compatible mode and the CPU is running in emulation mode. It's acting like a 6502, and that any code that's running on that 6502 in emulation mode is going to use page 00, which we happen to know when we take a look at the memory map. Page 00 absolutely is in fast memory. That's this RAM up here. It is not this RAM down there. Now with Apple IIgs firmware, I have no idea how that's working. Perhaps Apple IIe mode is entirely running inside of the E0 space up here and E1, and it's not using 00 at all. I don't know, but I'm assuming it still does actually, and that's how you can get better performance on this machine when you run it at 2.8 megahertz, even for standard Apple II software. So that shadowing functionality that we just manipulated is absolutely key, because in order for us to have the Mega 2, which is what generates Apple II graphics, display anything, it needs to have copies of the text and the high-res stuff in these memory locations in bank E0. And if you're using double high-res or 80 column mode, it has everything that's written into page 01 in the bottom of the memory map for the fast memory to be copied into E1. I hope my explanation of this makes sense, but what I'm trying to get to, just to kind of summarize it here, is that when the CPU boots in emulation mode, 6502 mode, and it's running Apple IIe code that doesn't know about these bank registers in this CPU, what's happening is that all of the code is running out of page 00, the beginning of the RAM space, and also 01 if it's going to run in 80 columns mode. Those banks of memory exist in the fast RAM on this motherboard. But then for the Mega 2 to be able to display anything to your screen, it needs to have this shadowing turned on, which copies any writes that go into page 00 to page E1, which is that standard RAM, which hangs off of the Mega 2. And then any writes to page 01, which is the auxiliary RAM, that second 64K for like the high res, double high res, that kind of stuff, that needs to go to E1. Well, clearly some of that copying is happening, because when we were in the high res mode, page 2, and I tried to clear the screen, we got those lines. So some amount of the shadowing's working, but not all of it, at least for those memory locations in that high res page 2. Now it looks like whatever shadows the memory from the text page 1, that's like a little chunk of memory, I think starting at hex 400, that doesn't even get copied over at all. So my assumption is those @ symbols we're seeing when we just look in text mode, that is all just zeros, hex 0. I guess that's maybe what the RAM is at initialization, or yeah, it must be. Or maybe the hardware clears it. I don't really understand what's happening. But it appears that any writes into page 00 for text mode never make their way over to the RAM that the Mega 2 is looking at. Okay, so you might just be thinking bad RAM. That's why we never see those updates. But that's where, and I alluded to this earlier, that's where the Apple II VGA card comes in, remember, because it's not looking at the RAM that the Mega 2 is looking at. It is just looking at what it comes across the slots. And it also is not getting those updates. It's getting the same screwed up updates that the RAM on the Mega 2 is, those lines that are appearing, but not all of them. And it's not getting the text updates, and it's not getting anything else. The other thing that is also getting shadowed, by the way, are any of those soft switches. There's a soft switch for changing into high-res mode, low-res mode, switching the text page, beeping the speaker. That stuff is obviously making its way over to the Mega 2. And I think whatever's going on with this copy process or the shadowing, we're lucky that it just happens to be shadowing those registers up in the C whatever locations. So I can affect change by beeping the speaker or changing the graphics mode. But clearly a bunch of stuff is not making its way over to that RAM, but the register writes are, or the soft switch writes are, and certain memory locations are. And we have a huge clue that the Apple II VGA card and the Mega 2, which is reading directly from RAM, are both seeing the same things. They're both getting the register writes or the soft switch writes or reads, that is, for changing graphics modes. And they're also getting some of the writes for filling in some of the screen buffer, but other ones are missing. So this is the thing we have to understand to try to figure out what's wrong with this computer. We need to understand why anytime the CPU is writing to this RAM hanging off the Mega 2, the Apple II VGA card is seeing the same screwed up stuff. Now, a good way to do that is let's just go to the slots themselves and let's take a look at what the address and data buses are on the slots. So there are the address lines, there are the data lines. The data lines go into this black bar here, and that makes its way to something called SD bus, which if you look here, there's a 74HCT245, and that is connecting SD bus to MD bus. Okay, so we got to remember MD bus, which goes to a bunch of different pages. The next thing we have to look at is the address bus, BA bus. So those are the address bus lines that go to all of the slots, and that also makes its way to a bunch of other pages. That implies that both the BA bus and this MD bus is used all over the Apple IIgs for peripherals and stuff like that. If we go to page 1 and we're taking a look at the CPU itself, we can see the CPU has data bus and address lines. Well, looks like the address lines are A bus and D bus. So not the same address bus and data bus that the slots are using. So that means that when the CPU is running code out of the ROMs, because we know that works, obviously, when it writes to screen buffer, the text mode, the graphics mode, it's not writing to the same data bus and address bus that the slots are on. Because the Apple II VGA card seems to show the same broken garbage that the Mega 2 shows, we can pretty much make the assumption right now that the slots on the Apple IIgs and the Mega 2 exist on the same address and data bus. That's what my hunch is. So if we go down to the Mega 2 page, this has got BA bus, A bus, and MD bus. Okay, so we know MD bus for sure. That's the data bus that the slots are on. That's the data 0 through 7, and that goes right into the Mega 2. And let's move over here. That goes directly to the Mega 2 RAM. So when something is writing to the Mega 2 RAM, that's that slow RAM, which that shadowing register should do, it should be writing to both the Apple II VGA card and the RAM. But that's just the data side. Let's look at the addressing side. So the address lines that the RAM uses, especially the primary RAM, which I think is this stuff down here, this RAM up here, by the way, these other two chips, I'm pretty sure these are auxiliary RAM. So that's that second 128K. And yeah, you can see the data bus here, AD bus, is that MD bus? Auxiliary data bus. So I have a feeling that specifically is that shadow memory on the Apple IIe. So it's really these two chips that are the primary RAM, UM4 and UM3, which when we look here, it's the two chips that are on the right. That's the primary memory. But the address lines that go to the RAM chips, this has to be multiplexed because this is DRAM. And that's definitely something that this, let's see, what's actually generating that? RA bus? Okay, it looks like the Mega 2 itself is generating that. So it's doing all the multiplexing itself. So it comes out of the Mega 2, it goes through these resistors, and it also goes to this RA bus that goes off to page 3, which I have a feeling is probably the video display chip, the VGC, because I think it needs this main memory here also for its super high res modes. Okay, so the addressing that goes to the RAM and the video controller chip, I don't think that's necessarily our problem, because remember, the VGA card, it doesn't see this stuff because this is only going to page 3. It's not going to page 6 where the slots were. And the address bus on the slots, I'm quite sure was this one here, BA bus. Yeah, page 8. I'm sorry, it wasn't page 6, page 8. BA bus. And A bus is what came off the CPU directly. So in between the CPU, this A bus, and BA bus, which goes to the slots and it goes to the Mega 2, is what? 74 HCT 245s, 2 of them. And something on page 1, which is probably that FPI chip, is generating the direction signal and the enable signal for both of these 245s. Okay, let's bring up the notepad and just kind of put our thoughts in this thing. So we know that A bus plus D bus, this is on the CPU and FPI chip. To get to the slots and the Mega 2, this has to go through a pair of HCT 245s, and that creates the BA bus. Just making sure I have my terminology correct. Yes, I do. And then the other thing is the D bus gets turned into the MD bus through another 245. So the data bus, when it goes to the slots in the Mega 2, that has to go through a different HCT 245, and that then creates the MD bus. And our last piece of the puzzle is that CPU writes to page 0001 shadow to E0 and E1 in order for the Mega 2 and the Apple II VGA card to be able to display that properly. Now the question is, what's generating this shadowing? My assumption is it's that FPI chip, because the ROM code doesn't know anything about the shadowing and the CPU doesn't know about it. So what must be happening is as the CPU writes to page 00 to say update the text screen, the FPI chip must be going, oh, the shadowing's turned on. Let me also write it to this MD bus and this DA bus. Let me shadow it over there. And that way it gets written into the standard RAM and also onto the slots. That's broken on this machine. And that specifically is what's broken. Well, this is where I'm kind of stuck, because this FPI chip, which I'm quite positive is what's doing this shadowing, is this what's broken? Is this why this thing's not shadowing properly? Like, it's obviously shadowing some stuff. Some soft switches are definitely getting shadowed, and also some writes to that second page is also getting shadowed. I think it's also happening on the first page of high res. So some of that is getting shadowed. And I'm pretty sure these are the signals that come out of this chip that are handling that. Pin 11 and 13, those are what control the HCT 245s for the address bus, and then the data bus ones are these two right here. Well, these signals, the DB signals and the AB signals, need to be turned on at the correct time. Now, I think this is really an addressing problem specifically, like either the 245s for addressing aren't getting turned on when they should be, so stuff is getting like written to the wrong place, or they're just not getting turned on at all, like they're only turned on some of the time. I don't necessarily think it's the data bus ones, although I guess it could be those two. I'm just trying to think. I guess it all depends on, like, if we write to part of the memory for the Mega 2 and it goes to the wrong place, well, that could imply an addressing problem. But maybe it's just the 245s aren't getting turned on when they should be. That's interesting. That's an interesting thought. Again, I don't think it's the Mega 2, because the Mega 2 does control all the access to the RAM that's over here. You know, it's its own RAM. The fact that the AVGA card is also showing exactly the same problems means that the problem is not the Mega 2, it's something to do with these level shifters or the commands coming to the level shifters from the FPI chip, because these level shifters also connect the main memory or the shadowing operation to the slots. You know, this kind of got me thinking, maybe there's a register we can write to inside the CPU while it's in 6502 mode that changes the bank that it's using to write to, or we could tell the CPU to write directly into bank E0. And with that, we could do a test to see if it's the shadowing that's broken or writes directly into that memory that's broken. I have a feeling the connectivity between the system, all the fast side of the system, like the CPU and the FPI, and this slow memory in the Mega 2 is broken. And that's why the Apple IIgs diagnostics fail, because almost surely that just goes into a mode that writes directly to that memory without using the shadowing, that is. It's just directly writing to E0 and E1, and that's failing, obviously, because, well, the shadowing's not working, and I guess that means the writes in that memory aren't working either, and then that's what's failing. But sadly, to see the output of diagnostics, even the stock 2GS ones, we need that Mega 2 shadowing to be working or be able to write directly into E0, and that's broken. So there we go, catch 22. I think what we need to start doing is taking a closer look at these bus transceivers specifically. We have the direction and enable signals for all 4 of them. Well, these 2 are shared together. Plus, we can take a look at both the input side and the output side because maybe one of these is broken. Incidentally, these 2 chips, which are closer to each other, these are for the address bus. These are the ones that create the BA bus, which is just something that's messed up. And this is the one that is handling the data bus. Let me just validate for sure. UI5. Yeah, so data bus, address bus. This is pin 1, which is the direction signal, and then that's pin 19 right there, or actually it's this pad on the board we can probe right there very easily. That is the enable signal. Right, so the easiest thing to do is because the Apple IIe has that diagnostic mode we can run, let's just get into it. So hold down both keys and we hit reset. While it's running, there should be tons of access happening to those chips, absolutely tons at all times. So let's take a look at these signals and see what we see. Okay, so this is direction. Maybe that doesn't change that much, but let's check the enable pin. That's just enabled all the time. Well, maybe. While the test is running, at least it's enabled. Okay, so the test is complete. Let's control break or control reset out of here. Don't really see anything happening at all there. I don't really know how it should look. So that is, again, that's the enable pin for these chips. And then this here is the direction pin, which is just high. And my assumption is when we have it high, that's going to copy everything on this side, on the left side, over to the right side, A to B. So let's look at one of the other pins that go, I don't know which one I'm looking at. So I am looking at the B side. This is what actually talks to the Mega 2 and the slots. And I am currently on, what is this one? UJ5. I think I'm on like pin 17 or so. So it looks like that. Now, if I start the diagnostics, the RAM diagnostics, see how it changed? Oh, for a second it changed. Okay, let's just look through these. See if any of them look screwy. I mean, they all look okay, I guess. All right, so that's on one of them, looks like that. What about this other one? Oh, that doesn't have anything on it. Wait, what? Wait, UK5? That's this one here. All right, so that pin has that. That pin just has nothing. Okay, so I'm on UK5 pin 11. So this is address line, what is that, 8. And if we start the diagnostics, it looks like that. So this is the side that goes towards the Mega 2, right? The 0 volts looks pretty good on this chip. But this pin, this is pin 9, or sorry, pin 12, address line 9, I see nothing. Literally nothing. Now, is that just because this diagnostic's not doing anything on that pin? Maybe. But I can tell pretty easily by just looking at the other side of this chip, that is address line 9. And address line 9 is also pin 8. So that's this pin right here. There's freaking activity on this pin. Lots of it. Okay, let's do this properly. UK5. If we look at address line 8, pin 9, that's what it looks like right now. So this is the side on the CPU, okay? This chip should be turned on and it should be copying everything from this side over to that side. Actually, let's just validate that real quick by checking that on UJ5. So I'm going to go on UJ5, pin 9, UJ5, pin 9. There it is. So this is what's coming from the CPU. Okay, right here, pin 9. A8 copies to B8, pin 11. So this is pin 11. There it is, same thing. Okay, UK5, I'm on pin 9, address line 8. That should be copied over to pin 11. And I go to pin 11, and it's there. Okay, cool, that's working. This is address line 9, pin 8, A7 on the chip, but it's address line 9, pin 8. Pin 8, the A7 copies over to pin 12, which is this, and there's nothing there. There is nothing freaking there. I need to take a screenshot because this is the CPU side and this is the Mega 2 side, okay? And right now, that is going to that. But what's not working is this does not go to that. So we see no signal. I mean, I should have done it a little bit better. Let me put it to green here because we know that, oh, that's worse. I know that this signal right here is not making its way over there. So it's there, like we see it on this side. We don't see it on that side. So that right there is telling us that either there's something shorted on the output side or that chip is bad. But let's keep going down the list, right? Okay, so what we're looking at here, and I'm on the green highlighter, is this pin 7. That should copy to pin 13, which is here. And as you can see, there's freaking nothing. So that's another dead one. So I'm gonna mark that up properly. I'm just gonna probe very easily what's on this side, on the right side, which is left on the actual board, only because there are little pads that make it very easy for me to do that. So that one has nothing on it. This one has nothing on it. This one has nothing on it. This one works, address line 14. And this one is working. I just need to validate once and for all though that, like for instance, A3, 4, and 5 have stuff on them right now. So let's quickly do that. These two are fine. So A3 is pin 4. Okay, that doesn't really have anything on it actually right now. Let's run the diagnostics. Okay, there we go. Let's check the other side. Oh, there we go. That one is actually working. Okay, so which pin is this? So this one actually is fine. This one's actually fine. That one is dead. That one is dead. And that one is dead. Okay. And I'm just going to do this testing real quick on this side. So that's good. That one's good. I'm just checking what's going into this chip. That one's there. That's there. And that's there. Okay. So the reality here is it appears that these 3 signals don't work. Address line 9, 10, and 11. That seems to be our problem, everyone. So that was this chip that we were just working on. I'm gonna get my marker and I'm gonna mark it just so I know which one is bad. UK5. I think it's bad. I don't know for sure if it's bad. I'm gonna put a little dot on there. I'm just gonna quickly run through that same methodology on UJ5. I'm just gonna check that everything on the Mega 2 side has activity on it. I think this chip might be marginally bad as well, because remember when we looked at it, let me bring up the virtual bench, UJ5, when we looked at it, I don't like how it's not really coming all the way down to ground. The other one was. On the pins that work on the other chip, see how there's a nice hard, they come down really nice and hard? They're not doing that on this other one for some reason. But let me just quickly make sure that they are all working. So I'm going to run the diagnostics. So this is facing the Mega 2, just checking every one of them. They all look okay. They're a bit kind of noisy though. I don't love that. It's the same brand chip as the other one. Oh, what's that? Oh, I think, okay, that was just oxidation. And just to make sure that it's not oxidation on these other ones that are dead, like I'm pushing really hard on it and it's not working. Let me just for fun check on the one that's doing the data bus. Just make sure that it has activity on all of its outputs. I think this one's totally fine. And that's because I think I talked about this one. It was writing like FF, all white pixels, or 00, all black pixels. It looked correct. It wasn't like there was any missing pixels there. We're just missing those address lines. That one's a lot of activity there. And yeah, okay. Yeah, that one looks fine. Everything on the Mega 2 side of the data bus transceiver is okay. It's this one right here. We're missing these 3 lines. Address line 9, 10, and 11. I have no idea how long this video is going to be because I've been talking so much. But I think that's our first sign there's a problem. Now here's the issue. That transceiver, those lines, they're going to a whole bunch of stuff on the Mega 2 side, right? They're going to the Mega 2 chip, they're going to the slots, they're going to, I don't know, a bunch of other peripherals and things like that. What if something is causing those to be shorted to ground? What I should do is if I turn this off, I should get the multimeter and we can, wherever it is, I misplaced it, here it is. I'm going to check those signals that aren't working properly and check that they're actually shorted to ground or not shorted to ground using the ohm setting on this. Because before I condemn that chip and just like yank it off the board, I want to make sure that the problem really is that it's the transceiver itself that's gone bad. Okay, so our problem pins, pin 12, let's check that to ground. No, 3 mega ohm. So it's fine. Because if it was really low resistance, like we had a physical short, it wouldn't be in the mega ohm range. Like we check this other chip here. Oh, that was the wrong chip. Let's check the one that's actually not working. I put a dot on it for a reason. Okay, how about this line? No, 4 mega ohm. These are definitely the bad pins. They all read about 4 mega ohms. Even the ones that work are 4 mega ohm, which is oddly different than the other one. The other one, well, that one's 4 mega ohm. 3.5. I guess it's all close enough. Okay, well, anyways, the bad pins on the chip that are bad, which is this one, they are not shorted to ground. I think it's that chip. I mean, it still could be something else on the bus that's causing that, but I think this chip is just failed internally. Okay, well, I don't necessarily have a spare because I don't really keep surface mount stuff. So I'm going to go to my spare parts and I'm going to look and rummage and try to find a suitable part to put on this board. That's the right form factor. Okay, I went into my spare parts and I found this network card, I guess, and it has a 74F245. It's a fast part. I think that's going to be just fine. This is an HCT part. HCT parts are very fast, and I'm pretty sure this one is going to work in its place. It may not, so if it doesn't work properly or this machine is unstable or crashy, then I will have to take that off and find a different one. These are LS, those are 244s, those are latches. Yeah, okay. I'm just going to seal this one. It's the same footprint as this. Let's see what happens. All right, there it is. There's a replacement chip, and I've cleaned it up a little bit. Yeah, you can tell it's been replaced, but that's fine because it has been replaced. The original is sitting right here. I guess we'll have to see what happens, right? What's going to happen when I turn this on? Are we going to actually see the Apple IIe boot screen or not? All right, just making sure that it's on the right way. It is. Here we go. 3, 2, 1. Yes, it freaking immediately worked. It just works. That was it. Oh, I can't even believe it. I mean, I can believe it. All that troubleshooting. Hey, it freaking works. I'm wearing my freaking work shirt. It's just a little worn out. Look at that, everyone. Freaking Apple IIe ROMs on a 2GS. There's the diagnostic mode. It just works. I love it. That is the power of critical thinking right there. Collecting evidence, figuring out exactly what's going on, get to the bottom of it based on visual symptoms, right? I didn't like take anything off the board. I mean, I did reseat the CPU and the sound chip and the video chip, but I didn't go and think, oh, it was bad RAM and take the RAM off and take anything else off. Look at that, system okay. It freaking works. That is so gratifying. Now the question is, I want to know, does the dead test ROM just work as well? All right, dead test ROM is on there. There it goes. Look at that. Just freaking works as well. I mean, really, today I learned you could just totally run Apple IIe software ROMs right on the 2GS with zero problems. Now, I'm pretty sure that the floppy controller probably is not going to work. There's no point to even let this finish. Well, I guess in case you want to just see what the dead test ROM looks like on a 2GS, it's going to run this for like 1 minute and 30 seconds and then give us the status screen. So I think that the internal peripherals will not work. So like the built-in disk drive controller, for instance, is not going to function correctly because I'm pretty sure that requires some amount of ROM code in the ROM itself to correctly control the integrated WAS machine and stuff like that. So I'm pretty sure if we do like PR number 6, even with the external floppy drive plugged in, it won't actually work. And without having to figure out how to like use the registers to essentially control the soft switches to disable the slot maker internal stuff and just use like a plugged in card, I think there's really no way to use the floppy drives with the Apple IIe firmware on here. But the 2GS firmware should now work properly now that I've swapped out that bad transceiver. So I guess we got to write the X to shame on here while we let this thing run, because this chip is bad. It is bad. And this other chip is suspect. I'm going to put a dot on it. I know it's working right now, but it just didn't look quite right because of the levels and stuff. But that clearly is okay. There we go. There's our status screen. That's what this does. And after a few seconds, it just runs again. But this is only going to test the lower 48K of memory, which obviously is part of this memory and part of this memory. Well, it really only tests the fast memory. It won't even tell us that this RAM is bad. But yep, there we go. It's working. Well, let's switch over to the original stock ROM. I just need to find my tool to pull the OneRom out. I mean, I could just program it with the 2GS ROM, but why don't we just go back to the original ROM and call it a day? Because I think this computer is probably fully functional at this point and 100% working. And while I'm at it, I'm just going to plug the floppy drive in. So there we go. Stock ROM, stock speaker, floppy drive, everything. Here we go. 3, 2, 1. There we go. And there goes the disk drive as well. So it works. Okay. So control break, and now we can run the diagnostics. We'll actually control open Apple escape, brings us our desk accessories. And this is where we can control the slots and stuff like that. So yeah, everything. Oh, your card. Slot 7 is a your card. So remember I was trying to boot off of slot 7 and I couldn't remember the default configuration. I guess it wasn't working because the slots, remember, are connected through this bad transceiver. We're missing those address lines. And yeah, there we go. I'm just testing if this is warm. Fast chip is slightly warm, I suppose. Anyhow, let's reboot this thing with the diagnostics and let it run through a full suite. So this looks different, right? The way the graphics weren't looking like this. And then this, I know, goes into like a super high res. There we go. This is super high res mode. This is the 2GS specific mode right now. This wasn't even working at all. We just got green with the solid green, and then we get an error. And then we got the gray, and this is where it failed. Remember this part of the diagnostic when this transceiver was bad. So definitely this diagnostic ROM was detecting that there was a problem talking to this standard RAM. So the E0 and E1 bank. So this test is somewhat comprehensive. Too bad it doesn't just output what it found over the serial port, for instance, because then we would have actually had information on what was going on a lot sooner. There we go. That's the end of the test. System good. That's what it does when the diagnostic works. Very nice. So there we have it. We have a working 2GS. Maybe I should just run some software just to be sure. I think everyone knows when I like to test Apple IIs, I pretty much have a certain piece of software that I run. Yeah, it does that every time. But it's loading. Yeah, this machine, there it is. Okay, it's running in fast mode. So what we need to do is we need to exit out, or actually we can do it while it's running, and we gotta change this to slow. Oops. There we go, normal speed. That's what we need for Apple II software, because there is no way for hardware timing to work on the Apple II. So basically you have to, it basically relies on the clock speed. So the sound plays too quickly, everything is too fast, even at 2.8 megahertz. So put it back to 1 megahertz. There it is, good old Fat City. It's kind of the definitive test, isn't it? At least for me it is. I played this game so much when I was a kid. I mean, it's not even that great of a game. I think the graphics are good, considering, 1977 machine, right? Yeah, there we go. There we freaking go. All right, well, that's gonna be it for this video. James, who gave me this machine, I'm sure is watching and will be super curious to know that, yep, it was this one little chip that had gone bad somehow. I'm glad that it was none of the custom chips, because obviously if the Mega 2 were bad, or VGC, or one of those other ones, it would have been impossible to find replacements without cannibalizing them off another Apple II. Meanwhile, I was just in my junk bin, found this old junk network card, and then was able to steal the chip off of it, even though it's not exactly the right part. Fast 245, it's good enough, it's close enough to HTT anyways. Clearly, it has no issue working. And there we go, a fully functional Apple IIgs. Well, I hope you enjoyed this repair. I found it really fun. As you can tell, I'm pretty excited that it's working. That was very satisfying. I was really happy I was able to get to the bottom of what chip was bad without just doing the parts cannon approach and pulling chips off the board and then like, oh, it's got to be the RAM. Going into this video, part 1, I was so sure it was the RAM, but obviously it was kind of RAM adjacent, but not really. And it was very handy for me to have access to, I'm just getting this card out of here, this Apple II VGA card. This certainly came in clutch. And I said when I first looked at this thing that these types of cards would be a great diagnostic tool for Apple IIs. And it really came through, because this let me know that the problem was not with the Mega 2 or the RAM, that it was actually affecting the slots as well. And I think I wouldn't have been able to tell it without this Raspberry Pi Pico based card. So there are a number of these now, including some that have HDMI, some that have VGA, stuff like that. So thank you very much for the folks who have made these. This one came from David Cooter, but there are others from other people. And I gotta say, very handy and really enabled me to get all those pieces of evidence that I needed to figure out exactly what was wrong with this. And I hope my explanation of the whole bank shadowing and all that garbage made sense. And honestly, today I learned, like I said, you can just run an Apple IIe ROM on a freaking 2GS and it just works. Like, that's super unexpected to me. And I think a lot of people might be surprised by that. Although maybe a bunch of people will be like, of course, that's how it works. I don't know. I wouldn't have suspected that, but that's a pretty cool little tidbit there, isn't it? So if you enjoyed this repair series, these 2 parts, then I'd appreciate a big thumbs up. But if you didn't, you know exactly what to do. And a huge thanks to my supporters. Their names go up the side of the screen to make it possible to do this full time. And you know, the usual comments and YouTube-y junk. And I guess that's going to be that. So stay healthy, stay safe, and I will see you next time. Bye-bye.